Hi, in this section we're going to look into categorical propositions and the logic that dominated most of philosophy for almost 2,000 years until the 19th century when we get into propositional logic. Categorical propositions are fairly straightforward. A categorical proposition is a proposition that relates to classes or categories. For example, the proposition all men are mortal relates the class of men to the property or predicate of being mortal. So this derives from the structure of sentences with a subject and predicate and the relationship between the two. And so beginning with Aristotle, subjects were thought to be identified by being of a particular type or category, and the predicates themselves were also thought to be of a particular type or category. And so categorical logic is an attempt to come to conclusions based upon the relationships between subjects and their predicates. Before we get into that and into the Venn diagrams that help us to picture these relationships, a few terms that the textbook lays out that will be helpful. The first four terms are the quantifier, the subject, the copula, and the predicate. So if we go back to our initial proposition, all men are mortal, the quantifier is all. So it basically tells you whether there's four quantifiers, as we'll see. It's all, or no, or none, some, and actually there's three: all, no, or some. So basically there's a universal quantifier. It says either all have this or none have this, or a particular quantifier, some have it. Then the subject is the subject of the proposition. In this case, men is the subject that is being spoken of. The copula is the verb that connects the subject with the predicate. In this case, it's are. And then the predicate itself is that which is being predicated of the subject. So in this particular case, it is mortal. So back to the quantifier. We can think of the quantifier as expressing quantity either as a universal or a particular, and also as a quality too, either affirmative, it asserts a particular predicate of a subject, or negative, it denies that there's a particular predicate applicable to a particular subject. The relationships between these types of quantifiers and predicates boils down to four key types. And historically, they are identified as the A, E, I, and O type propositions. So the A proposition is that all S are P. So the all men are mortal would be an example of an A type. The E is no S are P. So no fish are mammals would be an example of an E type proposition. The I is some S are P. So some men are philosophers would be an I-type proposition. And then an O-type would be some S are not P. Some philosophers are not rich. Actually, that would be most, but that's another issue. But so those are the four types of propositions. That basically boils down to all the different possibilities. Another key term that will be important to understanding the validity of categorical arguments is the concept of distribution. As our book sort of lays it out, a term is distributed if the proposition makes an assertion about every member of the class denoted by the term, or if it makes an assertion about every member of the class denoted by this term. So for example, in the A-type proposition, all S are P, the subject is distributed, but the predicate is not. So if we think about this, the subject, all men, what is being said of men is that they are mortal. And that's being said of every man. All humans are mortal. With respect to the predicate, it's not clear what predicate applies to. Predicate may certainly apply to things other than human beings as being mortal, and as a matter of fact, we know that that's true. All living things are mortal. So in this particular type of statement, the predicate is said of all cases of the subject. So the subject is distributed, but the predicate is not. In the E-type, no S are P, both the subject and predicate are distributed. So what this means, if we say that no men are gods, then we could say that no men, that something about all men, period, without exception, is that none of them are gods. So that's distributed. And of the predicate being a god, we can say that that predicate in no case is ever applied to men. So in both cases there, it is distributed for both subject and predicate. And the reason I'm going through this is later on we're going to look at some rules to determine whether an argument is valid or not. And this concept of distribution is going to be crucial to that process. So the I type proposition, some S are P, neither the subject or predicate are distributed. If we say some men are philosophers, we can't say anything about all men because we're only talking about some of them, and we can't say anything about all philosophers because we're not talking about what applies to all of that either. So we can say that neither one is distributed. And the last one, the O-type proposition, some S are not P. The subject is undistributed and the predicate is distributed. So we don't know everything about the subject, but we do know that the predicate does not apply to the subject. So we do know something that applies to all cases of this predicate, that it does not apply to this subject. So we could say that some philosophers are not rich. We know that the predicate rich does not apply to some philosophers. So that's it for distribution. The other concept that's very important is the concept of existential import. So in a categorical proposition, we say all men are mortal. The assumption is that there are men that we are talking about, so that they exist. So one of the issues that we will see in the sections going forward is whether or not to assume the existence of that which is being talked about. If we make conclusions about something and that something doesn't exist, that would be an example of what's called the existential fallacy. So for example, if we claim all Tom Cruise's movies are hits, the subject, Tom Cruise's movies, the assumption here is that there are such things as Tom Cruise movies, that they exist and that we can talk about them and predicate certain things of them and say that they are hits. But then we can say all unicorns are one-horned animals. Now, by definition, a unicorn is a one-horned animal, but a unicorn does not actually exist. So that's why in the first case, we have the implication of existence for Tom Cruise movies, but the latter does not imply existence. So as we deal with categorical propositions, there are two key approaches to this. The first is the traditional standpoint, the standpoint that goes back to Aristotle. And for Aristotle, we can correctly infer conclusions from categorical propositions if the things we talk about exist. And so it's not a fallacy. But the more modern standpoint, attributed to George Boole, what's called the Boolean standpoint, is that in any universal proposition, we can't immediately infer the existence of that which is spoken of. So that'll be something that we'll see with the examples going forward and with the homework exercises as well. Now, one way to think through a lot of the relationships that we will be talking about in the next couple chapters is to picture the relationships between the subject and predicate, and a Venn diagram is one of the ways in which that is done. It's a very common way in which that's done, and you use a circle, two circles, one for the subject and another circle for the predicate. And basically the circle, for each circle kind of, you can see it as a territory, and that territory holds everything of that particular category or class. So everything that is S is contained within that circle S, and everything that is P is contained within the circle P. But as you can see, the circles overlap. So in that overlap, there is the possibility where something can be both S and P. So if we say all men are mortal, for instance, we would say that every subject, men, has the property of being mortal, or P, and so there would be that overlap. But if we think about that, all men are mortal, if we look at this picture, this is actually the way to draw out the A-type propositions, all men are mortal. The shaded area on the left means there is nothing there, means it's empty. And so if the subject is men, then what this is basically saying is that there are no men that are not mortal, right? The only men that exist would be in the overlapped area where it overlaps being mortal. And so that's why the overlapped area is not shaded, because there aren't any men that do not have the property of being mortal. And so that's how one would draw the A-type proposition on a Venn diagram. The E-type proposition would look like this. Let's take no philosophers are rich. This is an example. So that would mean there are no philosophers that overlap with the predicate of being rich. And so the overlap, the area where the S and P overlap, would therefore be empty, or it will be shaded. Okay. Now we get to the I type. It says some S are P. Some athletes are rich, let's say. And so this X corresponds to where something exists. So there is something that exists. Doesn't say how many things are, but there is at least one thing. So that's why the X is put in there. And so there is something that overlaps both being an athlete and the predicate of being rich. And finally, the O-type proposition. In an O-type proposition, where we say some S are not P, so we can say some athletes are not rich, there are some athletes that are athletes, but they do not overlap with the predicate rich. And so that's why you have the X outside the P circle, but within the S circle. So you'll have several examples of this to work through in the homework exercises. But it's fairly easy. As you kind of do several of these, you'll kind of get the hang of it, and it'll become fairly clear. And it's a good way to sort of picture the types of relationships that we're talking about. And in the next chapter, when we do categorical syllogisms, we'll have a third circle that gets added, and we are able then to draw inferences, right? Inferential conclusions, namely arguments, as we have been talking about, from these types of relationships. So, speaking of inferences, one of the things that emerged as logicians discovered primarily during the height of the Middle Ages was that there are certain contradictions between these A, E, I, and O type propositions. And basically what a contradiction is that if the one is true, right, as we can look at the top left, all S are P, its contradiction is some S are not P. So if all S are P is true, then some S are not P would be false. So in a statement or in a sentence, if you read, it is false that all men are immortal, let's say, then it would be the same as saying it is true that some men are not immortal. So that would be the contradiction. So anytime something contradicts something else, it flips the truth value. And the way that this works is that you don't need to test it. It becomes what's called an immediate inference. You'll know that if this is false, then the contradictory must be true. So for example, we can see that through the Venn diagrams that will help show us the picture so we can see this. So if all S are P, the A type, is true, then some S are not P, the O type, is false, and vice versa. So if we can look at the top right, that's the all S are P. That means that there are no S that are not P. So that's why it's empty in the left section here. That's why it's shaded. But if you look down at the bottom drawing, there is something in there. So you can see that those are the opposite. One has nothing there, the other one has something there. So you can visualize the contradiction here. And then with the other contradiction, if no SRP is true, and that is where the overlap between S and P is empty, so it's shaded, then some SRP is false, and vice versa. So again, The top part, it's shaded, meaning there's nothing in the overlap, and the bottom one, there's an X there, meaning there is something in the overlap. So in sentences that are written in the type A, E, I, O types, as you go through the homework exercises, if it ever says it is false that, then you know you want the contradictory of the type of statement that's being used. So if it is false that all S are P, then you'll know you want to go, it is true that, or you don't need to say it is true, you'll just simply assert that some S are not P. Okay, so that's where the modern square of opposition helps, that you can immediately translate one sentence into another type of sentence and preserve the same logical truth value. There's other ways of going about translating sentences as well, and these are in our textbook referred to as conversion, obversion, and contraposition. And through conversion, aversion, and contraposition, you can change the way a categorical proposition reads while preserving the truth value. This does not work in all cases, though, as we'll see. So let's do the first of these three. Let's do conversion. Okay? As you can read in the book, conversion does not preserve truth value in all instances. Conversion itself entails switching the subject and predicate. In the A and O types, the Venn diagrams are different, so we cannot immediately infer the same truth value. But in the E and I cases, we can. So if we look here, that A type, all S are P, we can't say all P are S, right? It's not the same picture. And if we think about it, if we say all cats are mammals, that's true, but we can't say all mammals are cats. That doesn't preserve the same truth value, okay? The top right, some S are P, or no, right, S is not P, or no S is P, that's right. We can switch them and preserve the same truth value. And so in the E and I types, we can switch them back and forth. But in the A and O, we cannot. And the drawings, if you draw them out, as we had done before in Venn diagrams, you can see that it doesn't give you the same picture. If it doesn't give you the same picture, then it's not preserving the truth value. Okay, so for aversion, in aversion, the quality, the affirmative or negative, is changed, as is the complement of the predicate. So P becomes non-P, and so all A are B becomes no A are non-B. Okay, this is sometimes an important way to translate sentences. So immortal would be translated into non-mortal. So that's where this type of translation becomes helpful in doing something like that. In all four types of categorical propositions, the truth value is preserved after aversion, as the Venn diagrams show. So if we say all S are P, so all men are mortal, we can say if we say the aversion would be no men are non-mortal. That would be, meaning immortal, then that would be true as well. So in all four cases, you can do aversion and you end up with the same truth value. And lastly, we have contraposition. In contraposition, you switch the subject and predicate places and with their complement. So all A becomes B. Right now, all A are B becomes all non-B are non-A. Truth values are preserved in A and O types, but not in E and I. Now on tests and so on and so forth, you'll be able to have your books at hand to be able to keep in mind these contrapositions. But the key to understand with these is that you can use these to translate sentences and maintain the same truth value, because that's what's key to logic, remember, is that you want to preserve the truth value across a series of propositions in order to arrive at a conclusion. If the truth value becomes contradictory, then you know you have done something wrong somewhere along the way. So that should be enough to be able to get you going with the exercises for this section. These are the exercises. Again, they are going to be listed at the course website on Moodle, And after you've done the exercises, you can check the answers at the back of the book, and then the exercises video will give you some of the answers that are not listed at the back of the book. Good luck.